All right, so we went over how to draw the three rays. Remember, the three rays were, one was in parallel out through the focal point, two was in through the focal point, out parallel, and then the third one was through center. Now, the same three are going to apply, but last time the first two were really the ones we went to. This time with lenses, you're going to find that drawing the center is really, really easy. So, excuse me, there are two types of lenses. There are concave and convex. I prefer to call them converging and diverging, but it's completely up to you. This one right here is called a diverging lens, and it's also known as concave. And once again, it's because it's kind of caving in, you know. This one right here is converging, and it's also called convex. Okay, so you're going to have one of those two types of lenses. We're going to start with convex. So here we go. Let's take my object, and just like mirrors, I'm going to set it way far away and get rid of my concave mirror. I'm going to put my lens right here in the middle. Let's actually make it a little bigger. There we go. So we're going to do the same thing we did before. I want to draw my rays. Now, in mirrors, the ray was, you know, it bounced back. That's what mirrors do. But in a lens, these rays are going to go straight. Remember, it's always good to go to the middle through. So the first one goes in parallel. It hits this converging lens, and then the ray converges on the primary axis, and it goes through the focal point. Now remember, you only need two to make this work. Your second ray you're going to draw, yes, you could go in through the focal point, you know, and out parallel and all that other stuff. But for lenses, I found the easiest line to draw second is the one that goes right through the center. Okay? And just to modify things so they fit on my screen here, I'm going to bend this one down a little bit. I'll move my focal point in there so it looks legit. Now you see that my lines do meet, and yours are all measured out, so you won't have the same problems I'm having. I'm just kind of sketching a freehand here. You can see they do meet. It meets, and my object is upside down. Because I'm not using dotted lines, it's going to be a real image, and it's a little bit smaller. And there you go. So let's move our object and try a new place. All right, here's everything we got. Once again, I'm going to get rid of my cat's eye, not my cat's eye, my hourglass, and let's put the arrow right here. Actually, let's put it at the focal point. Now, remember what happened when it was a mirror at the focal point. It makes you wonder if the same thing is going to happen. So let's find out. So in through the focal point, or sorry, in parallel, out through the focal point. And then your next line is simply through the center. Holy smokes, they're parallel. So just like a mirror, if you place an object at the focal point, you get no image at all. Now let's try moving it even closer. I'm going to take my object and I'm going to move it really super close to the lens here. Let's put it inside the focal point. Get rid of this guy. You come over here and make you a little bigger. There we go. All right. So, do your lines. First one goes in parallel. Out through the focal point. Second one goes through the center. And once again, you could do that other second line, but I like the ones that just do this. And you find that we got ourselves a little bit of an issue here. Not only do they not meet, they're actually diverging on the right-hand side. Well, that's weird. But it also means the same thing it meant for the mirror. When a mirror diverged on one side, what we did is we took the reflected rays and we drew dotted lines. Now we're going to take the refracted rays. Actually, you know what? I should make that dotted. We're going to take these refracted rays and we're going to draw them back. And what you see is that these lines do meet. It's just way back here. So what I end up with is a upright, and this is much, much larger. And this image, because I had to use dotted lines, is virtual. Now, where have you seen this before? This is a magnifying glass. When you use a magnifying glass, you put it near what you want to look at, and it projects a larger image. Now, you can't tell just by looking at an image if it is real or virtual. You have to draw the ray diagram or just know it by heart. But this is how a magnifying glass works. It utilizes this convex lens, this converging lens, and the properties that go along with it to make an image that is way bigger. Kind of cool. Okay. Now what we're going to do is we're going to do one of these hourglass lenses. So I'm going to put my image out here, put my cat's eye lens right here, and here we go. Now, just like our convex mirrors that only had one type of image no matter where you were, this is the same case for a concave lens, a diverging lens. So it's going to follow the same general rules, so that's good. So let's do this. Now, ray goes in. Now, it diverges, so it can't come down to this focal point on the right. It's going to diverge away from the axis, but in such a way, let's see if I can make it close, that its refracted ray comes back through the focal point. Your second ray is your center line. That hasn't changed. That goes right through the center. And since you go through the center, it doesn't really diverge at all. And remember, this does bounce back on itself, like that. And what you're left with is an intersection, of the reflected rays, right? Oop. Almost able to make it smaller. Not tedious at all. There we go. I end up with an arrow that is upright, and I should have made those reflected rays dotted, I'm sorry. It is upright. It is definitely virtual. Let me actually do that. That's going to bug me, so let's just do it and get it over with. So here's this one. And here's this one. You don't have to make the sound effects, but it really helps. So because the lines are dotted, I've got a virtual image here. So this is upright because it's pointed up. This is definitely virtual, and it is definitely smaller. And that's it. No matter where you put this object for this diverging, this concave lens, no matter where you put your object, you're going to end up with that same exact image. Smaller, virtual, and upright. Okay? Well, there's all your ray diagram stuff. Go back and check it out. For the most part, I've covered all the interesting pictures. There are some other ones. The last thing I'm going to do is I'm going to give you your equations. These are all in your equation sheet, which you may, of course, use. I just want to make sure that I put them down here. Now, if it ever asks you to calculate these things, you're going to have to use some equations. But don't forget, they're all just relationships. Okay, this first one is about the size. This is the size of the image. That's what the I stands for. And this is the size of the object. And this, of course, is your focal point on the left there, your focal length. And that's if you're given the focal length and you need to find the height of something, you just use that equation. It's very, very basic stuff. The next one is hi ho is equal to negative psi so. Told you, it's all just ratios here. Now, once again, this is size on the right. Over here, this is height of the image. And down here is height of the object. And just to be completely clear, when I say object, I mean the red arrow we started with. When I say image, I mean the red arrow that we mathematically found. Okay? So if you need to calculate anything, these two equations are really all you need. I guess if you wanted to be really thorough, don't forget that the center is twice as far as the focal length. But that's pretty much it. So those two equations, three technically, are what you're going to do. If you ever end up with a negative number, you see this negative sign right here, that simply means it's upside down. That's all that it means. So if you end up with a height of negative 3 centimeters, that just means it's upside down. Okay, I have said plenty. I hope you're having a great break. I hope this was helpful. I hope the packet goes well. I'll be checking Edmodo, so if there are any severe issues, you can just give me a shout, and I will see you when you get back.